Wow, I miss you so much.
So today doesn't have the introduction of new concepts. The goal I want to achieve is to fill your notes with all the shapes, with an example of each shape so that you can see how it's drawn, how to analyze it, resonance type stuff. So I invite you to draw along with me. Ask questions if something doesn't make sense, and then at the end of the period, I'll give you 3 structures to draw, and one of you will get to come up to draw one of them for the class. So we will find out who it is. What I've done is I've made a list up here that kind of mirrors our discussion yesterday, but it's the way that my brain looks through any molecule that I am asked to channel. Thank you. You should channel your molecules too, that I'm asked to draw. So this is the order by which I do my my analysis. Now, the AP is not going to ask you to do this kind of full analysis for a single molecule, but just so you have a starting and ending point on everything you should know about a Lewis structure you're drawing. So I'm just going to dive right in. Stop me if I do something that is doesn't make sense to you. And let's draw some shapes.
Stop. Drop and roll.
All right, we've got chlorine trifluoride. So my first step, quiet please guys, is to get a valence electron count. For chlorine, it's 7. For 3 fluorines, it's 21. Therefore, my molecule gets 28 valence electrons. And now I've got my valence count. The central atom will be chlorine. And I know that I want to bond the leftovers with single bonds. I then make the octet happy everywhere. There's no hydrogen, so everything wants 8. And now I'm hoping that I've drawn 28. Yes?
Like when it has like 3, like CLF3, you always draw it like that?
You mean,
Like how do you know how to draw it? Like where to put the other?
so once you establish your central atom, I always just draw it as symmetrically as I can. So I'm just going to give each one a side the way I would a Lewis structure. Whether the side of chlorine that you leave empty doesn't matter. Because keep in mind that this is molecules floating through space. So a moment later, the lone pair, the way it's drawn now, we're not done, but the lone pair would be on top as it rotates through space. So one doesn't make it more correct than the other. Have we drawn a total of 28?
Yes.
No. We are in a situation where we've only drawn 26.
No, that just
All right. So that's a little different from yesterday. But if you remember from last year, as long as we have a central atom that can expand its octet, this is actually an easier problem to fix because you can just add the missing electrons.
You have the lenses too, right?
Yep.
Can you make another lone pair on the CL?
So chlorine is going to expand his octet to make room for those other 2 dots.
Kiriana.
The expanded octet stuff is the hydrogen.
No, it actually
Hybrid.
it's not. It's she asked if expanded octet's covered in the hybridization lecture. It's not. It's alluded to, but I can post. I have an expanded octet lecture from pre-AP I can post. But all you need to know is that if it's in row 3, row 4, row 5, row 6, or row 7, it can expand its octet.
Chlorine's in row 3.
That's the entire deal. Chlorine is the one that expanded, not fluorine.
It's in row 3.
Chlorine's in period 3.
Let's see if this is true. Okay, you're right.
It's 3. It's just 3
You're telling the truth.
Quiet, guys. I can't hear him.
Remove electrons, you get rid of 2 lone pairs.
Right. So now we are at our grand total of 28. So let's check formal charges to make sure we don't need to, nothing is too funky. Hey, all of my fluorines are identical, so I can just find one of them. Fluorine on the table is 7, and I subtract the number of electrons it controls in the Lewis structure, keeping in mind that all of the dots count and half of the lines count. So it's 7. So all of my fluorines have a formal charge of 0. Chlorine is sitting there with 7 on the table. And in my image, he's got 1, 2, 3, 4, 5, 6, 7. So hey, we've got a perfect molecule.
Wait, so why is it like when you're doing the dots, you count the lines as 2, but then you're like not?
Because when you're counting formal charge, you're looking at the electrons that the atoms have possession of. When you're counting the total dots, you're counting at how many are there. This chlorine has 1 electron from each of those pairs, even though there's 2 there. All right, there are no resonance structures because we don't have any pi bonds to move around. What's the shape?
T-shape.
It's T-shaped. Make sure that you can do this part. I know it's T-shaped because it's a central atom with 5 areas of electron density, and 2 of them are lone pairs. If you look on your table, there's only one shape that has that exact description. And when I say table, those of y'all at home, it's in the slides. All right. What are the angles of a T-shape?
Less than 90.
All right. It's a less 90. All right. Now remember, the less only matters if you're comparing a shape to a shape. If someone just said, what are the angles of that by itself, less than 90 is a good enough answer. You don't have to say less, that will confuse them. The less is so that you know that this has a smaller angle than one that I've listed as just less than 90. And don't think I'm crazy. That's a super common practice in AP. And finally, what is the polarity?
Polar.
It is polar. Because if you look in your table, it says that a T-shaped is always polar, even if these are identical atoms. All right, it's those lone pairs that's throwing off the negativity of the atom.
How long do you think it takes to spade an animal? Like, say I wanted to get my dog spaded, how long would it take me to spade? Huh?
You can drop them off and like pick them up.
Drop it. No, I'm not doing like a Banfield pet hospital thing. I'm going to the SNAP clinic there.
If you go to the SNAP clinic, you drop them off at 8 a.m., you pick them up at 4 p.m. That's how I got my wife fixed. Don't watch this video! Okay.
I was about to say, didn't he refer to his wife as a dog?
There we go. I did see all the videos connect. There's continuity. You should watch the end credit scene of this video. Okay. Here we go.
Wait, back the hell up.
Starting with a valence count, iodine will give us 7.
28.
Chlorine will give us 28.
Minus 1 plus 1.
That charge will give us 1. Again, you've got to stop me if you don't understand something I write. This is all we're doing today is a bunch of this.
Oh.
So if it's minus, it's plus.
You were born in the first year? What's that?
2001.
It's minus, plus.
Yes, well, that's an extra. We're counting electrons, and a negative charge represents an electron. So what are we dealing with here? 36?
I hate when I get the alert notifications from AP.
Hey, look, I was nice to you on that last one. On the last tangent.
That was really good.
On the last tangent. All right, so work with me now. My central atom is going to be iodine. And I will connect the others. What did you ask?
When you're determining the central atom.
It's usually the less electronegative of your choices, but the other way to commonly look at it is whatever you have the least amount of. But less than negative is more chemistry. My octet needs to be happy everywhere. Iodine is good, but chlorine's not. So let's go ahead and make chlorine a happy little camper. So we're still on this octet step, hoping that I've drawn 36. Is our number good?
No.
Absolutely not.
We're at 32. We're way off.
Yeah.
All right, but it's nicer when we're short because you just add them. All right? Can iodine expand as octet?
Yes. He's a baddie. Kiriana. Let it happen.
I'm going to check my formal charges. All of the chlorines are identical to each other. So for chlorine, it's going to be 7 minus 7. All of them are sitting here at 0. So that's good news. Iodine is sitting here at 7 minus 1, 2, 3, 4, 5, 6, 7, 8. All right, so he's sitting here at a negative. All right, and that negative, you know, of course, at that point could have been predicted because we knew when we started that this was a negative molecule. Now, guys, keep in mind, if they don't ask you for formal charge on something, then don't add these marks here, all right? I'm just showing you, 'cause I mean, really, when we're done and we say that we're good, we should be erasing those formal charges. I'm not going through that practice so intensely with you, but these formal charges should not be in your Lewis structure. I just want your notes to show you what we've talked and thought about. There are no resonance structures because there's no pi bonds to move around. What's the shape?
A tetra.
Square planar, very good.
Yeah, that's what I got.
Because only a square planar has a central atom with 6 areas of electron density, 2 of which are lone pairs. I understand that by the end of today, most of you will feel decent about drawing the stuff. You've got 8 calendar days to know all of your shapes and angles.
Okay, wait. So wait.
No. You get nothing on the test.
We don't get to know like what our shapes are on the
No. On the AP exam. That's what when this unit started, I told you this unit's not hard. It's just there's a huge memorization increment to it. Increment component.
1, 2, 3.
All right. Hey, what's the angle of square planar? 90 degrees. And make sure you do use that supplemental sheet though, because I don't want you to say, oh, at 90 degrees. It shows you where the 90 degrees
Or
is.
is it less?
It's not less. It's exactly 90.
I just want to make sure.
All right. And then what is the polarity?
I need
It's non-polar.
It says cool.
All right. It doesn't. Not on square planar. It doesn't.
Oh, I looked at the one above.
All right, so don't do that. All right, and I understand it's a challenge. All right, but I'm sorry, because your chart tells you right away that this shape always, as long as these 4 things are the same atom, that those 2 lone pairs are going to cancel each other out.
Am I not supposed to be looking at this chart?
That chart is your secondary chart. The only reason I gave you that secondary one was so that you could see where they draw the angles. I want you to use the chart that I put in the slides. That's the AP Cummings wrote it. It must be perfect chart, right? Okay.
Is the test gonna ask for all of this?
No, not on a single problem. But it'll give you a molecule and it will ask for one of these, usually. Let's do carbonate.
do.
like carbonate?
It could.
Is it just gonna give us that?
It could. More commonly for this, it won't. It'll just give you the
Like
formula.
for your test,
But-
are you gonna put, 5 carbonate?
Why do you not know your polyatomic ions?
Say someone that did.
For somebody that did
Just
it.
say if someone.
Let's get a valence count. Carbon's a 4, 3 oxygens is an 18, and those 2 negatives is a 2. Carbon will be a central atom, and I'll bond my other dudes with single bonds.
This sounds so sorry.
I need an octet everywhere. There's no hydrogen, so everybody wants 8. So I'm going to give everybody what they don't got for Valentine's Day. Aww. Me and oxygen have good chemistry.
Really?
Oh,
What does your wife
oh,
think
he
about
got
it?
you.
I pick her up at 4 o'clock.
David, anything you might say?
We're still on the octet. Are we done? Are the dots good?
Eight,
Now they are,
16,
yeah.
24.
Yes.
Yeah.
They're
too-
not.
No, there's too many.
There's too many. There's 26.
No.
2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. All right?
Okay, we should do a double bond.
So this is the other direction. Erase 4 dots, add 1 bond.
I
1,
was
2.
right, I was right.
3, 4. All right, I don't care what oxygen you steal from. All
Oxygen.
right, I don't want to hang anybody up. Why'd you pick the bottom one? It don't matter.
Yeah, for real. You don't
Don't denaturate your disintegrate.
And by doing that, you will see that the octet is still present everywhere, while now the total number is 24.
Why did you have to have that body buster right now?
Let's check formal charges to make sure nothing's out of whack. All right. Hey, we've got some different stuff here. These 2 oxygens are the same, and both of them have 6 on the table, but 7 in the molecule.
Negative.
It was on yours. I just said-
So they're both sitting here with a negative formal charge. The other oxygen, the double bonded one, is a 6 minus 6, so he's a happier O.
Oh no. But our
Go ahead, say it. And what's carbon's formal charge?
Oh, carbon. I thought it was chlorine for some reason. 4 minus 4 is 0.
3?
And it was neutral.
All right, it's 4 on the table, and then he only gets half of each of those bonds, so 1, 2, 3, 4.
I don't know why I wanted that to be chlorine.
When you add this all together,
is it
have
2 negative?
Negative 2, like for the.
And but they will. If it's an ion, they will. So as Reagan pointed out, these these charges are exactly what we would have expected them to be, based on carbonate. Hey, I see a pi bond. Do we have any resonance structures here?
Yes.
How many total resonance structures are there?
3.
There's 3. Because remember that step where we chose an oxygen to steal from? We could have chosen a different oxygen. In other words, that pi bond could have been there. That would be a second resonance structure. Or the pi bond could have been there. That would have been a third resonance structure.
There.
So make sure you don't skip
So do we
that.
have to draw it out every time? We just have to know how
It depends on what the question's asking. Because keep in mind that really the molecule in reality is an average of all the resonance structures that exist. So that's good enough. Now if it says show all resonance structures,
What if it? So
then you would draw it 3 times.
you need. Oh my god. The perfect atom, right? Can you get the perfect?
No, because carbonate is negative 2. There is no perfection here, just like my first period. I don't have a first. Oh, I'm sorry. What is the shape? Trigonal planar. What's the angle? 120 degrees. Trigonal planar. 120. And what's the polarity?
I don't know. I'm scared.
Non-polar. Now, for those of y'all that are like, how are they getting that? Guys, most of them are just reading it from a chart. All right? It's just, it is. All right? You've got to memorize that trigonal planar, as long as these are all the same atom, it's going to be a non-polar molecule.
Because they're all the same.
Yeah, there's no, because really, so here's the other thing that I'd like to mention. At this point, it would be more correct to slightly redraw it, because you see this oxygen here? It really should triangulate this direction. Because remember, these electrons geometrically are trying to escape each other. That's the whole reason we can predict these shapes. So really, this O, you see this empty area out here? It wouldn't be empty. This O and this O are going to shift slightly this way to get as far away from that O without getting close to each other. So, and once they pull in those directions, it's non-polar. Now, is this acceptable? Yes, because you've done all of the steps right. All right, but it's not as pretty as it could have been. Hey, we're getting closer to one of you drawing one for everybody, so I hope you're paying attention.
Talking mushrooms.
That doesn't make sense.
No, I didn't say it.
Let's do two more together, though. All right. Is anybody bored yet? I get bored doing this over and over again.
I'm bored.
Here we go. We need a valence count.
I just figured out how to understand it.
All right. Silicon gives us 4. 5 chlorines gives us 35. That negative symbol gives us 1.
You're so short.
All right. 40. I'm going to put silicon in the middle. All right, and then I'm supposed to bond everything else with a single bond. All right, now right away you need to make sure silicon can expand his octet. He can, but I like for you to think about it.
So he couldn't?
Well, that's not going to happen to you, because just keep in mind that the only guys that can't are the ones at the very top of the table that are never going to, aren't going to really be able to fall into a situation where that's such a big number. So it fixes itself. It's not like it's not going to give you a false compound. But I just like your brain to be like, oh, silicon can do this, instead of just blindly drawing lines. The octet rule needs to be followed, so none of these chlorines are happy yet. Yeah, well, silicon's beyond happy. He's already expanded, so I'm not even thinking the number 8 there anymore. Working on the octet, can anybody tell me, are we in okay shape or not okay shape right now?
I don't want
Yeah. Am I counting?
We are good.
We're everybody ready? We're
Yeah, I think it's perfect.
good. Eight.
It's 40. All right.
Why did you draw the dots?
I just shorthanded that one. Well, sometimes it's good for your notes to see once that you can shorthand it. Let's do formal charge to make sure everything's all right. All of the chlorines are identical, and they're all sitting at 7 minus 7, so that's amazing.
This one wasn't even that hard.
Silicon is 4 on the table. What is he in the compound?
5.
He's 5.
So I was gonna say 4.
And again, we could have predicted that. This is about to look a little messy, I'm sorry. But because this is an ion anyway.
Huh?
There are no resonance structures because there's no pi bond to move. What shape is he? Trigonal bipyramidal. Only trigonal bipyramidal has a central atom with 5 regions of electron density, and none of them are lone pairs.
We got 2 angle measures.
What are they?
90 and 120.
We have 90 and 120 in our trigonal bipyramidal.
Appreciate it, huh?
What's the polarity?
Non-polar.
Nonpolar.
Are we gonna see a seahorse? A seesaw or a seahorse one? Or no, sawhorse. There it is. Sawhorse or seahorse.
All right, last one together. Huh?
Is that flavored water? Crazy egg water?
Valence count. Central atom. And then bond the other 2 guys. I'm using foresight on my angle there, so sorry.
It's central.
I just don't know how to draw this any other way. You can, it's fine, but it's just more correct. Octet rule, the hydrogens are good. Remember, hydrogens only want 2, but sulfur needs some more. So now we are sitting at 8 total. That's good. We can check our formal charges, and you'll see that hydrogen is at 1 minus 1, sulfur is at 6 minus 6, so that's great. Everything is 0. All these pauses are for you to ask a question.
Oh, okay. Hey! No. Do not point.
Right, yes, the brackets, she asked, do we have to put the brackets around it if there's no charge? No, the brackets are for the charge.
Okay.
All right. There are no resonance structures because there's no pi bond to move around. What shape?
Vent.
What angle?
A rectangle.
Vents are angular.
Less than, right?
Vents are angular. Less, 109.
It's a less, 109.5.
I told you it's meant for the beginning.
All right. And what's the polarity?
Polar.
It is a polar molecule.
Can I help you? That's what I thought.
How are we feeling about this?
I'm feeling great.
Want to draw 3 by yourself?
Yeah.
Here's the last 3 molecules, and then we're going to call it a unit. One of you will be chosen to come up here and hang out with me. But first, I want you to draw them. There they are. The red dudes. If you get stuck, call me over. Be patient with yourself. Do a full analysis. No, I'll give you paper.
That's what I'm saying. I agree. I really do. I don't. You guys want competitive one?
She really broke her neck.
Go ahead. No, yeah, you don't do this with ionic. These are molecules. Because we're all talking about sharing electrons. The crystals don't share electrons.
Good.
You've been really blessed. Josh touched me. Josh himself touched me. You gotta repeat. 4, 8, 12.
What the hell are you saying like that for? I'm not gonna do it in my head. I don't have those memorized. I've been memorized since like 7th grade. Not even.
That isn't right.
Not even. No. If I have a country, what's the use? 48. That's 48. Okay, we're doing lines. I can't know what dots.
Thank you.
Bless you.
Oh, I wasn't asking. Diego's voice is more angelic.
Was it you? It was not. Oh, it sounded like you.
No, it wouldn't sound like his voice is angelic. It would sound like an angel singing.
Say no.
I don't think it's that anymore.
What's the supposed to be?
Wait, that's perfect.
Oh, so you're just dumb. You were extra.
Stupid Charlie. Is it Charlie? Feels like Charlie. Like literally. It isn't. It's
I got 48.
You stupid. Why would you take out that guy? You're so dumb. I hate him. Deep. What? I don't know what you're talking about.
Okay.
I don't know what. I don't. What are you talking about? What did you tell me?
Yeah, I know.
No.
I know they were taking it off my back. I'm doing it.
Uh-oh. Stinky.
I cannot wait for summer. Right on the knee. Maybe
I tried to make copies, but the line with the copper.
Do that door and then come back.
Mr. Cummings, could you please come here?
Who's that? Oh.
I would like these to be checked, please.
We did it together. Oh, it's 3. Wait, but it has 4 areas. Which one did you say was 3?
No volunteers.
We need
Is that CL?
There's so many
Yeah.
reactors. I got pages.
Wait, what was the other?
It's up there. It's in green.
Oh, the Russian freak out.
Is it one person doing all of these?
One person's gonna do one of them, and I'll do the other two. It takes two. Y'all are really slow.
Do the first one. I think he meant really fast, but he misspelled.
You misspelled it or
He misspelled it. Yes.
Okay, should I give my mom the
So
schedule
misspelled.
of like
Filming it.
or should I give her next for her birthday? Or should I give her both?
Okay.
Yes. Because I can give her the movie pack for Justin. And then I can give her now for her birthday. Because the birthday's on Saturday.
So we'll be selecting a person in a moment, but if you don't consent to be on camera, then I'll just turn the camera away from you. Sorry?
That was me blowing on the dice. Sorry, I'm blowing on the dice.
So let's go ahead and head over. By the way, Aspen is hanging out at 1-1, it says. We're going to go to cluster 2.
Why is it at 1?
Hello,
It's
ladies.
supposed to be at Jacob.
Oh, it's supposed to be a
Yeah,
Jacob.
it's supposed to be Jacob.
I didn't even know Aspen had expiration date.
All right, and then we will go to seat. Come on.
Let's go, Mara.
Yeah,
Yeah. You can. Did you not want this on you? No.
Why?
You will now look at the roadmap. Then I'll show you homework. All right, so you study the roadmap, and I'll show you the answers in just a minute.
Respected students.
Like a little kid.
Be a vlogger. Oh my god. Vlog.
Yeah, Mara.
You do like Cody's family.
So this is the bunch of the laptop.
She's doing a good job. Doing a very good job.
Ew. She's really going off, Mina. He's just amazing. All my chemistry teachers have hated when I draw best because I like to do my own shapes. I'll be like, oh, what shape? Like a sun.
What?
You should record yourself playing every single character of the Saga Sword, but like making a movie, but you're the only character.
That doesn't sound like it would take years to do.
It doesn't. It sounds like take a good month.
A good month. How do I get into the H.O.C. Mountains?
What? Get a bunch of weights. I want to start imagining.
No. That's perfect.
Like the main characters from High School Musical. That's what he looks like now. That guy from.
We're back. How'd she do?
Perfect.
Isn't it supposed to be an expanded?
Yeah.
She did a good job.
Yes.
Well, what's that two part?
Why is it sea salt?
Well, we've got.
She's correct.
I got sea salt.
Yeah, no, it is sea salt, but I think she just forgot to show her.
She did it. She showed it. It's the two part. It's that little two number she had right
Oh,
there.
yeah.
She just missed her lone pair there.
That's what we're saying. That's the 2.
The two is her lone pair. The number 2 is her lone pair.
The little 2 next to the S.
No, she went for formal charge there because your sulfur is going to be 6, but it's going to be 6 minus 1, 2, 3, 4, 5, 6. But other than that,
They don't tell us the charge, right?
they don't tell you what.
The charge, like if it's on there. Like if they
Like
put
if
the
there's
element,
charge.
they're gonna put the charge, right?
Right. Yeah. Well, if the compound is an ion, they have to tell you because it would mess up the number of electrons that you'd have anyway. Right. For the first one, we should have gone this route.
What? I thought somebody was doing every one of them.
I said
2, 3, 4, 5, 6, 8. No.
What is this?
All right, so there's my crazy SF6. What shape did you say he was? Octahedral. What polarity does my octahedral have?
Non-polar.
Non-polar. All right. For your ClF5, we should have gone. No, it doesn't. Because it's rotating around anyway. What shape did we say that guy was?
It is square pyramidal.
Square pyramidal. What angle does square pyramidal have?
It's square
Less than 90 degrees.
Less than 90 degrees.
Square pyramid. It's